I'm really hoping that what I'm going to share today is going to change your life. I'm really hoping that what I'm going to share is going to inspire you, to show you what's possible with network automation and network programmability, but also get you motivated to learn to code using Python. I'm really excited to announce that I'm collaborating with Chuck Black, and have been for a long time now, on the development of a software product that you can have access to for free, but also have access to 52 weeks of Python training for free. Chuck Black, in my opinion, is one of the best people to teach all of us how to use Python for network automation and network programmability. Time really does fly. I uploaded my first Python for Network Engineers with GNS3 video in April 2017. So I've been training network automation, network programmability for quite a long time now. But things have moved on since those days, and I want to show you that that is very basic network automation. I've seen a lot of other examples on the internet of network automation and network programmability, but in a lot of cases, I find that it's a network engineer learning coding and then teaching other network engineers coding. In other words, they are approaching the programming piece from a network engineer's perspective. That's what I did, and I think that's very valid. But to take this to the next level, I've joined forces once again with Chuck Black, who's a software developer with networking knowledge. He worked for HP for many years, developing network monitoring software. He's got 12 patents. Chuck doesn't like me to boast about him. Let me just say, Chuck is an amazing guy, an amazing developer, amazing architect, has many, many years of experience. And he's going to teach us how to become a software developer or programmer or coder, whichever term you prefer. He's taking all his knowledge of software development, software architecture, and he's going to teach us for free in his 52 weeks of Python course how to create software like the Quokka software. So rather than just doing basic scripting or making the mistakes that we shouldn't make as new coders, he's going to teach us how to code properly, how to think like a programmer. So he is taking his programming knowledge and applying it to a networking context. Chuck has done this for many, many years. He has written software once again for HP. He's developed code for huge financial institutions, names that you will recognize, other networking vendors, which I won't mention here. Chuck is, in my opinion, one of the best people in the world to teach us this stuff because he knows programming, but he's also worked in a networking environment and worked with software-defined networking and all the buzzwords of the last few years. I met Chuck at HP over 5 years ago when he was developing a SDN course for programmers and I was developing an SDN course for network engineers. And we've kind of combined our knowledge and our experience. I coming from the networking side, he coming from the programming side, and we've created, well, he's done all the work. He's created this product called Quokka based on things that I would like to see. So I, as a network engineer, have told him, Chuck, it'd be fantastic to have this feature, and then he's added a whole bunch of features to the Quokka software. Now, what's really amazing is Chuck is doing all of this for free. You have free access to the software. You can use the links below this video to download a virtual machine that has this pre-built. You can download the code from GitHub. Chuck is giving back with a hope that he can change many of your lives. I won't have time to go through all the features of this software in this video. I just want to show you some of the features that are available, some of the cool things that this software can do. But I can tell you this, he's working on some really exciting new features to the software. What Chuck's done here is connect to various Cisco DevNet sandboxes so that you don't have to have a network device available. So by default, this will connect to some Cisco DevNet sandboxes, and he's also written his own SD-WAN virtual devices. So you can see the vendor and operating system here is Tilak. Chuck spent a long time developing software with Tilak for big financial institutions and big networking vendors. I can't mention the names here, but you'll know them if I mention the names. But he's done this because one of the problems people have is when they want to write software to interact with network devices, they might not have network devices. So we've got some Cisco sandboxes and we've got some Tilak virtual devices. Let me show you some of the features that I really like about this software, which you will learn to code if you go through Chuck's Python course. So let's do a trace route to this Cisco CSR sandbox. Hostname is this. IP address is this. Click on trace route to the device. After a few seconds, you'll see something like this. Now, obviously, your trace route to that device will be different to mine. This is a switch in my internal network. This is my internet router. I'm connecting to British Telecom. So you can see Autonomous System 2856, BT Public Internet Service. Goes through a few routers, and then it goes to the BT Global Networks Autonomous System. So this is basically showing you all the hops across the internet to get to the Cisco Sandbox. It goes via reach, goes via GTT, and then it arrives in the Cisco Autonomous System 109, goes through a bunch of routers, and then hits this device, 64.103.37.51, which is the Cisco CSR router. So this software has once again been populated with various Cisco sandboxes. Let's go to this Nexus device. But you could add your own devices to the software, and you could do trace routes to any device that you want to. So once again, I'm going to a Cisco switch, to my internet router. I'm going via BT, the BT Global Network, other ISPs, and then I arrive in the Cisco Autonomous System and go through a bunch of devices. Okay, so that's one basic component to the software, trace route. You can once again add your own devices by opening up this YAML file and adding devices. Okay, so let's have a look at a configuration diff. Click on this little icon, and I can see that these lines of code were added since the last configuration backup. I can see the full configuration of the device if I want to, so there are 83 lines of code here, but none of that code is changed. Scrolling up here, I can expand 266 lines of code. None of that code has been changed, but this code has been added since the last configuration backup. Let's have a look at another device. So let's have a look at this Nexus device. So we can see here that the running configuration has been changed. We can see that some loopback interfaces were created. And if I expand this, this is the code that hasn't been changed. This is happening in real time. People are configuring the Cisco sandboxes, and this software is continuously SSHing to the Cisco sandboxes and pulling back configurations. You can change that interval if you want to. So if any configuration changes have been made to the Cisco sandboxes, you'd be able to see that. But the same is true for any device. You can add your own devices once again to the software. As an example, here is my Cisco switch running Cisco iOS. Quokka also gives you device status information. As an example, we can see that this device is currently offline. Let's have a look at the Nexus device. So display device status. I can see response time, CPU utilization, availability, memory utilization of that device. I can look at the facts of the device. You can see what type of device it is. I can pull back a configuration of the device in real time. The software is pulling back configurations of the devices on a regular interval and then showing a diff of the device configurations. But this actually connects to the device and pulls back a configuration in real time. So there is the configuration of the Cisco Nexus device running in the Cisco sandboxes. So on the CSR sandbox, let's have a look at the ARP table of the device. Okay, this may take a while to display, but there's the ARP table on the device. Let's have a look at counters. That also may take a while to display, but there you go. It's pulled back the receive and transmit octets and packets on that device. This is happening in real time. Again, Chuck is going to teach you how to write code to do this. Let's have a look at services. This is any website as an example that you want to monitor. So you could monitor a website using HTTPS. You could check if the DNS resolution works. You could monitor using NTP as an example. So here I've got two websites, courses.davidbombal.com and davidbombal.com. So let's do a trace route firstly to courses.davidbombal.com and see if there's a difference between the trace to that website and the main davidbombal.com website. So as you can see here, I hit my local switch, my internet router. I go through the BT autonomous system, and then I hit Cloudflare. So that website is being hosted in Cloudflare. But the main davidbombal.com website is not. So if I do a trace route to www.davidbombal.com, you can see that I hit my switch, internet router, go through BT, and then I end up in the 1&1 Internet Autonomous System. This website is hosted by 1&1, which is a web hosting company based in Germany, but has a big presence in the UK. So you can see that this website is hosted by a different company to the courses.davidbombal.com website. So you can see visually all the hops to get to that website. You can see the autonomous systems that you go through. But what this does is it allows you to monitor the availability of a website. So if I click here, I can see the response time of that website. I can see the availability, and this will just keep on refreshing. You can set a lot of these intervals, but notice I can do that for various websites to see if they're up or down. You can see that I lost connectivity to the BBC website on Tuesday the 27th. And going to Google, let's have a look at Google. You can see same thing happened. And that's probably because I shut this virtual machine down and it wasn't running continuously. Now, Chuck and I are working on making the software even better. So one of the things that are coming in a later release is the idea of having a central node which controls worker nodes. That means that you can do trace routes from devices all over the place. So you can create these worker nodes in different parts of your network and do traces to various websites from those worker nodes, and also check availability from those worker nodes and see all that information on the main quokka device. What the software also allows you to do is to discover devices in a subnet. This is the local subnet. What I can do as an example is filter for a device and then scan for open ports on that device. So these are the well-known port numbers. So we can do what's called a standard port scan of well-known port numbers, and then we can do an extended port scan. And I think something a lot of people will like is the fact that we can capture packets to a device. So what I'll do is start a capture, refresh any packets to that device, and you can see a lot of traffic is going to that device at the moment because that's a default gateway. If I ping that device and then refresh the packets, you can see ICMP packets here. And then I can actually view the information of the captured packet. So as an example, there's ICMP once again. Here's an SSH connection. But the idea is that quokka can capture packets sent to the device. But what makes this really exciting is in a later release, which hopefully will be released very soon, we have a distributed model where we have worker nodes that you can place all over your network, and you can run a capture on that remote device. So I could place a worker node, which is basically a virtual machine, in a remote site, and then tell quokka to capture packets on that worker node, and then I can view that information on the central device or the central monitoring station. So rather than just capturing packets on this local VM and only having visibility of the local subnet, you could put worker nodes all over your network and then get them to capture the packets and then forward that information to the central monitoring station. Now, really important, Chuck wants me to emphasize this. This isn't a commercial product. This is licensed under the MIT license, which means you can do anything with this. You can create your own versions of the software. Chuck has created this to inspire you so that he can teach you what's possible with Python. So he's going to show you in the course how to create a whole bunch of this stuff. But we believe that it's important that you see what's possible, what you could create yourself. So not only have we created this product, which you can download and run in your networks if you want to, but obviously with the MIT license at your own risk, but you'll also learn how to create this yourself. Now, there's a whole bunch of other parts to the software. Chuck and I are continuously thinking of new ideas. Please join my Discord if you want to give feedback and have questions about the software. Please put your comments below this video and let us know what you would like to see added to the software. The main goal here is to inspire you and teach you how to create software yourself.